different solution? Or what problem does it solve if we switch to having two separate services and communicate through web interface between them?
Well, I mean, the web interface doesn't need to be the protocol in which they communicate. They can communicate. Dimitri, you had another idea, right? For communication.
Yeah, we can use a socket file, but I think in this case, Zookt will be a very simple proxy. So it wouldn't have any logic in it, and you would interact with the Rust sidecar essentially directly. If you send a request under a specific path, maybe it will be a API web server sidecar or something, and everything else, kind of like Nginx proxy pass, will be passed to the sidecar, and in the opposite direction, but for receiving tasks. And we've been discussing basically sending messages so that we can version it. We only have a single API, and then we have different types, maybe tasks and callbacks, and we can extend it if we want later. So it's just a message.
Yeah, I understand these possibilities. I'm still not sure about the problem which we are trying to solve with this.
So there's two things I think that will become blockers. Right now, I'll just show you the code from what I've seen. Can you guys see my screen?
Yes.
So let me remove this terminal. At least from what I see, we have this index builder. Where is it? Here it is. Should pull up index builder. So we have index builder, right? And so we have this index repository. So this is retrieving the data from Gitaly, right? But then there's a specific file that we added, a bunch of logic for maintaining the different directories and whatnot. Where is it?
GraphDB, it's like it's the client or the structure that's responsible for
Do you remember the file
store.
name? Is it Graph Indexer?
There's Graph Indexer as well. Yeah, there's a bunch of files.
So we have essentially from what I saw, we have like business logic of I thought I had my NeoVim thing set up, but it's not working. Where is it? I guess it's under knowledge graph, right? No, this isn't it. Or maybe it's graph.
The knowledge graph here is responsible for calling the bindings. So this is like bindings are only called from this file.
I see. Okay. So we have the index repository. This is where we get different stuff. Where is it where we actually call the bindings? Do you know where that is?
Knowledge graph file. That this is the file that calls the bindings, and it's being called from the graph index.
Yeah, here it is. Yeah. So this is what I'm saying. So if we have just this, right? This is nice because we'll have it provides an interface, right? But now when we want to start doing more complex things like namespace querying, because these are different files, right? When we go to query and we want to query across 10 different graph databases, as an example, right? You will have to organize the FFI where the indexer itself has business logic baked into it to find the different namespace graph files and run the Kuzu query, right? That's an example.
No. My understanding would be that if you want to run query across wall namespace or something, you handle this on this inside this GitLab Zookt indexer which takes care of opening all the necessary connections simultaneously and run the query function to query these databases.
And this is implemented already.
Sorry, this is the gap here. That's okay. Now I see what you're saying. So the gap is that in the knowledge graph side, you cannot you're going to be literally rewriting half of the querying logic throughout the knowledge graph query crate.
So let's dive in deeper into this querying logic. What exactly
Yeah.
do you mean? Because so far, this was not discussed anytime before. I mean, so far, assumption is here is the cipher query you get from Rails or whatever, and we run it on knowledge graph. We can do some
Yeah, so
preprocessing. This
that's what I'm explaining.
preprocessing can be calling
There's a
some FFI or whatever, but then we run the cipher query.
Yeah, so that's what I'm trying to explain. There's a lot of logic on the knowledge graph side for querying. Also, we want to expose MCP on the querying side. I think it's best if the knowledge graph itself exposes the MCP and all of the tools, right? So if you upgrade the knowledge graph on the server side, it exposes the full MCP interface, right? And you can return that as part of like a proxy request in the web server. And the reason why there's a bunch of logic is because we have a lot of compression that we've enabled. So let me pull up my terminal. So this is the way Michael designed it, because he's the resident expert for database stuff, but we have a ton of different things in here. So if you look at even just MCP, we have all these different tools in here that we'll want to expose maybe server-side versions of them for the consuming client to consume. In that case, we're going to have to write a bunch of FFI code to expose this. Versus if we had treated it as a proxy, we can just treat this as like a Rails gets information, passes as a request, and returns the tools. Sorry, give me one sec. I'm just gonna outline one more thing.
But the exactly same interface we are talking about by calling this service can be done by this FFI, yeah?
I mean, you can, but rather than just doing take request, forward request to knowledge graph server, you'll have to do take request, create knowledge graph client or whatever, create the connection, which I don't know how we'll handle multiple connections in that case, through the knowledge graph FFI. I'm saying if there's no way we can do the connection via like Go Kuzu unless you want to write a bunch of logic and basically reduplicate a bunch of this stuff here is what I'm essentially saying. And if we go to the querying crate, where is it? Database indexer. I forgot where all the code is. Where is it? Where's the querying crate? Did we move it? Oh, I think we moved it. Yeah, here we go. So we have querying, right? And so we can't just take a cipher query from Rails and return JSON results. There's like a bunch of mapping that we have to do under the hood to convert. It's literally just a simple example, but it gets more complex than this. For right now, we're storing where is it? We're storing enums like node types. I forget where exactly it is. Maybe relationship. Here it is. So here's an example. So we have these different relationships types, right, that are stored in the graph base database. But right now, Kuzu doesn't support like enum types that you can like index and compress. So you'd be storing it as a string, right? But when we query, we want to be able to query by these different relationships and yada, yada, yada. And in order to do this, what we're doing is we're creating internal mapping from these enum types essentially to an integer and storing that integer for compression and for space reasons into the database. Otherwise, for every node that you add to the graph, you'll be adding this string plus the actual data itself, plus any other data that can be represented. This was like, at least what Michael was saying is like, for columnar databases like these, it's like 101 you have to do. So what we're doing in here is we're doing this mapping. And then when you go to query with the Cypher query, we actually build the queries ourselves in the here based on the tool call itself. So we have a tool that's defined. The tool is mapped to a specific Kuzu query. And we build the query in the knowledge graph itself, the runtime, and run it, establish the connection, and all that connection logic is already handled in here, and we've figured out a lot of that. Then from there, it gets the results, and we remap the results according to the schema that we define from what we expect from the Kuzu query output. We remap that to something that can be returned. So if we go with the FFI approach, I'm just saying that, I mean, we could theoretically just make it accept an arbitrary query string, right? But at that point, you might as well just proxy it as a request to the input. But if we want to establish the connection part as an example in the Go binary, we're going to be rewriting a ton of logic, is what I'm saying.
So
just
regarding, okay, so I wasn't aware of this query rewrite, like that indexes are used instead of relationships or something like that.
Sorry, I wasn't making that clear. I should have led with that.
So if the query rewrite is needed because we use some custom database representation, then is there a reason why we don't extract the query builder and execution to two separate steps? Like we call the query builder through FFI and then it returns the build query, which we can then handle.
I'm just saying
because
that
it seems that it mixes two different things, like building query and coupling it with execution. Yeah. So
what I'm saying is we'd be basically rewriting a lot versus if we just had all the logic, the querying, a connection establishment, all go through one service. You guys can just come in, and if we need to update, for instance, database connection logic for handling different memory, right? Allocating X amount of memory, we don't have to do that in a Go binary, or if someone from the knowledge graph team needs to update on the server side, oh, I need to go to the Go binary to update it there, right? Versus if we just had it all as one thing in here, it reduces the operational burden by like a lot, in my opinion. If you disagree, let me know. But I'm just saying there's like a lot.
I think that we are underestimating the complexity of building these two services running together, and it's not necessary. I mean, I'm happy to dive deeper into the use cases or problems, but it seems to me that okay, for building the query,
what would be complex about adding if it's a Helm chart? What would be complex about adding a new Rust binary into that Helm chart? We already built the binary.
So we add another binary. Then whenever we make a change, we have to do the changes on both sides of the service. And
right, I'm saying what exactly would be the blocker or make it challenging to ship a separate Rust binary, assuming we don't have to worry about omnibus, right?
Maybe I can elaborate on that here. Like when I was working on the sales project before moving to the code creation, I was involved in adding these new services like topology service and the router, and I have seen how much effort even for GDK, like adding this to GDK, and how many problems might happen and how many complaints from people might saying, oh, it's like the service is not running, I have error or something. And this is only GDK, and we haven't even talked about like delivering it online. I think, as I mentioned before, one of the problems we wanted to solve with having FFI is we don't want to deliver another service. It's just like it's baked into the Zoc indexer. I see your points. Like I see there's maybe some points about, okay, maybe it makes sense to split this into another service to reduce duplication of code, but having another service is also is a lot of things to maintain, infrastructure and GTK wise, and probably might be also a performance problem, but I don't have numbers to judge about it. So yeah, like there might be some problems that might be inherited with another service.
Dimitri, what do you think?
I think we're not really discussing a new service right now. We're discussing adding another binary, sidecar binary to the existing service. And that allows us to make it optional. So if you have this new binary in your path, it's a additional feature ability, basically, of the service. If not, it continues to work as normal.
That was the
So
proposition, not like an entirely new Helm. Well, maybe we could think about that, but later on, but not an entirely new service. It would just be you have one node, it spins up two processes, the Zuckender proxies, indexer process. Is this what we talked about, right, Dimitri? This is kind of what we were thinking.
Yeah,
One
I've
process.
posed basically a short overview in the issue that we would have 4 processes instead of 2, and 2 of them will be Rust processes.
So it's similar to the initial approach that we have taken, which was like calling knowledge graph as a CLI process to index,
Yes.
but
Very simple.
it's long running service instead of short running. It's
Exactly.
like it's okay.
That's the proposition, essentially.
Okay.
Sorry if I'm like, I didn't mean to make
So-
it big and scary. So I'm not saying rewrite everything.
it means implementing this service-like process around the knowledge graph instead of having it as a simple library, and doing the communication interface between both processes. Either if we send it through standard input and use standard output or whatever we choose,
Yeah.
then it's an additional complexity. Yeah. So
I think it's worth it though, compared to the complexity of building a new FFI binding and potentially rewriting a lot of logic in the Go
but
land.
we already have FFI binding, right? So it's more about
Right, I'm saying we need to
adding
update.
more function to the FFI binding if needed, but the process is already there, right?
I'm still against using FFI for querying. I wrote about it in the thread before because it's going to involve so much unsafe code. But yeah, maybe it's still probably a valid idea.
Well, I meant rather for building the query if needed, as Angelo pointed out, that we need more logic from the knowledge graph Rust library.
I'm saying it's
build
going to be some cost up front for sure. I'm not disagreeing there for building the proxy aspect, but then after that, it's just a proxy. Like the Go area is just a proxy, and you then can accept the request, and all the logic can happen under this one project. And we just have different server side stuff. We have client side stuff, which we were pretty much doing anyways, right? So it's just saying instead of FFI, accept a protocol, and then we can have that be whatever communication layer that we want. But there's literally just not an entirely new service that's deployed, but 2 separate processes. That's the proposition, because then on the querying side, literally you can do something simple like get request and forward to dash MCP on the knowledge graph Rust side, and we can then add flags to the different tools we want to expose for MCP on the server side, if that makes sense. Rather than if you want to add a new MCP tool, for instance, or something like that. I mean, we could have it via FFI, but you still have to go over that FFI layer where you have like a function or something, but you still have to maintain the connection logic, the passing it to the FFI library, grabbing whatever string that's built out of it, like the Kuzu query itself, for instance, Cypher query itself, running that, Then you have to pass it back to the FFI to get that data and map that data to the correct stuff, then return the result. That's a lot of work versus just you get the result, the thing from, you get the request, you proxy it to the service takes care of everything and returns the result on the query side. And then when we want to add new server side items, it's going to get worse, is what I'm saying. Does that make sense? I
Can
can
you provide more details about this MCP use case? I'm not familiar much with the MCP, so it's not clear to me what exactly is being exposed regarding
so we
this.
don't want, for operational reasons, I really am like super against putting logic into Rails for MCP. Like we should literally just have a endpoint that goes to the service, the knowledge graph service. It obviously takes in auth information and passes auth information to the Zooked service / knowledge graph service, right? But we have a bunch of MCP tools that we've defined, and you could theoretically create an FFI binding for server-side MCP, and it just gets the string like the response, right, or builds the response and sends that. That's fine. That's not that complex. But if you have something like this, where just as an example, like here's Rails, here's the service. Imagine this is the Rust FFI or Rust library. This is the Kuzu database. This is the Zooked service. From here, you get the request, the MCP tool call, right? So imagine you get the tool call. The Zook service will then have to come here, go to the Rust library to build the query. Then after it builds the query, it's going to return the result. It's going to take that query and run it against Kuzu in the current design, right?
Yes.
Then it's going to take that result, come back here, and then that result needs to come back to the Rust library to map the types and all other post-processing that we do, which is a lot.
So what is this post-processing done on Kuzu result?
Like taking the enum type and mapping it to the correct string representation, as an example.
Okay.
There's a number of post-processing steps we do.
And these types translation, I mean, using numbers instead of relationships, strings. This is the only purpose is storage size.
Storage size and maintenance, and there's a bunch of other logic too. I'll have to ask the team. But yeah, there is like, we went back and forth on it, and it basically came out to where we need to do some form of post-processing. Like we're not going to be doing raw Kuzu queries for sure.
But if you use FFI, we don't have to do this. Like library, the Rust library is already part of the Zooked service, so it already has direct access to the database, and that's exactly what's happening now. Like now, when we do the indexing, we give the graph database path to the Rust library, and Rust library goes and indexes and.
So yeah, I'm saying we can do it over FFI, but at that point, you might as well make it a separate process and have it being a long-lived process. That's what I'm saying, because the maintenance burden turns into, we can completely get rid of FFI and just proxy the communication directly.
Maybe the question is why do we want to get rid of FFI? I know that we already have some problems and we wanted to discuss them, like regarding the library, shared library, and these things. But the question comes back is why do we want to get rid of FFI?
I think it would just be, to me, it would be simpler, right? Because rather than you just need to upgrade the Kuzu binary in your thing, and then the Go service just becomes a proxy and an abstraction service for orchestrating the different replicas, the nodes, etc. And then you can just think of, for testing, for everything, you both can go and spin up the knowledge graph, spin up like a web server or whatever, and then this is the expected payload you would expect from the Zook service, and you can test all of your logic there, and you don't need to touch anything else. That's what I'm saying, essentially. And you could do that with FFI, but again, like we have the whole build pipeline and the issues with FFI, unsafe code, potentially memory gotchas later on, right? I don't know. Like there's a bunch. And then also we can't do long-lived connections. Then later on, when we want to do namespace stuff, right? Where we want to query against a namespace of different items, that I think is going to get even more complex. Versus like if the knowledge graph service gets the request, and let's say it's a namespace request, right? It can get all the permissions for the given user, map. It knows which namespace graph to point to. Like the logic is in the Rust service itself rather than the Go service, and knows which namespace graph to point to. It can go to that specific graph itself and run the query. It knows all where the files live for the specific stuff. Versus if you might have to replicate that on the Go side. That's what I'm saying, essentially.
I mean, the new piece of information that I think me and Jan are getting from the sync call today is that doing the queries on the Kuzu database is more complicated than we thought. We thought it's just string, but now we thought, like, we realized that okay, it's there's way more to it, that it requires a new solution.
Yeah, I think it's news for us that there is a bunch of logic you are implementing on knowledge graph side related to pre and post processing, which we were not aware of. So I think that one of action items we can do going forward is that we have regular meetings of knowledge graph, because I wasn't aware of anything of this is happening. So it would be great to actually invite everybody and being more transparent about what is happening, because
we have it documented, but we were just moving so fast. I think it was just we didn't set up a sync to but we definitely should. That's why as soon as we could.
So thank you very much for these details. Do you think you would have time today to put this into some issue so we can discuss it in depth and transparently, like what exactly is the problem, and also mentioned what is your vision with namespaces, because it differs from what I would expect how we tackle cross namespace queries. So maybe we can discuss it on issue so it's visible to everybody.
Yeah, of course. Yeah, no, that's definitely the plan. I just don't know. That's why I was bringing it up to you guys, like to at least get your thoughts, because again, I'm not married to any solution. I'm up for whatever the team is best. I'm just raising this as it's going to get more, like the query side is going to get way more complex than we initially thought, and it's only going to get worse. Versus if we bite the bullet now, it might be harder at first, but it should hopefully reduce the operational burden. We can stick with FFI if you guys think we should, but what are you saying, Dimitri?
I was going to say that, in my opinion, with these Goku's problems, the effort to, let's say, fix the problems, maybe link it statically or create this new lightweight binary, Rust binary, and the proxy is comparable. So that's why I think it's important to make this decision now and not wait until we maybe try to fix Gokuzu and then still get rid of FFI down the line.
Why is the shared library not included as also a possible solution? I know that also like it's a problem to keep it up to date and download it, but I don't see it like listed as possible solution.
So shared what?
Shared so the problem that we are having now is that Google wants shared library, not static library, shared library, and it's just like downloading some file and putting it there. I know there's problems with it, but it's also an option. Is there a big problem with it?
I'm
So
confused.
in my,
You mean?
oh, sorry.
No, go ahead. Go ahead.
In my opinion, that's not really an option for us because that makes it a mandatory part of the build. So if we use this dynamic library, the Go binary will just refuse to start without it. And whereas if we use a separate Rust binary processes, these can be optional. If we can find them, the service can still run and provide Go-based services. So that's the main distinction, because we'll break everything right away if we require this dynamic library.
Also, like
Okay.
concerns too. I don't know if it was right of us to have two Kuzu binaries in the first place versus just have one binary for Kuzu and you install it. Like we should have either had it all, like having to install Kuzu twice essentially, because if you install the knowledge graph FFI, that's Kuzu built into the Rust aspect, and then you're also installing Kuzu again, right?
Yeah, but also with this information about the querying and how complicated it is, yeah, now I understand probably like Google is not like not the way to go. Okay, yeah, I was wondering about that before the call.
And this was really inevitable because querying would have been like this regardless, right? Because we found that using raw Cypher queries is not A, for security reasons, but B, for actually getting useful information for the LLM and having it be more deterministic is it's not the pattern we should be going with. So that would have been different, but also for size reasons, for performance reasons, like we have to do the special mapping for Kuzu. Yeah.
So two things. First of all, regarding this library build, my understanding is that the concern is about whether how problematic is it to build it, but I think that we haven't checked this yet. I mean, how big problem is build it statically, because this is exactly what Rust bindings does. It just builds the static library with the dependencies. So I don't see a big problem with doing exactly same with Go. So I would hope that this on itself is not a blocker. Well, it's something to check, but I wouldn't consider it blocker at this point as we didn't check this yet, right?
I've suggested to actually reuse our own bindings for the querying part, and I think Amar has raised a bunch of points why that's not the best idea. Don't remember all of these, but I think combining that with everything we've heard today, it makes it less of an option for us. So, and that's my point. I'm not saying it's not possible to solve.
Yeah, I was like when I was writing about complexity and unsafe memory, I raised these concerns before knowing about the complicated queries. So now I see that there's an elephant in the room that okay, maybe we have to bite the bullet here, and maybe okay, we go with the FFI approach, or we go with the unsafe memory development approach. Yeah, it's a different information now. So please, like, don't take my comments before this call seriously.
And second thing, Angelo, you mentioned performance. Sorry, security concern. What exactly do you mean that we can't run Cypher query for the database?
When we implement a namespace pattern later on, I'm still working on this. So this is something that I'm working on in addition to the stuff that I'm doing. You
So
want to.
So you never want to allow or handle permissions outside of Rails. This should be done on Rails side. And this is exactly or one of the main reasons why we went with this separate per project or per namespace databases is exactly the security.
Yes.
And I don't think there would be ever a possibility that the Kuzu would do cross repository searches on its own without having the exclusive list of IDs of namespaces which it can query.
Yeah, that's
So,
exactly what I'm working through actually. I've been chatting back and forth with Dimitri. This is separate. This is like because it's
okay.
business requirement eventually. Uh, but yeah, the idea is essentially you can either ingest data during the task time and take those tasks and build the relationships, and you can add the traversal IDs at that time, or you can actually just get all the user objects and find the different relationships for the users. And then when it comes to query time, you start at the user node and only traverse from the user node. So you have the embed permissions bed in. That's like a standard graph security mechanism for graph database applications. Or we take the traversal IDs and build those traversal IDs during query time, and just filter out any nodes that don't include the user's traversal IDs. That's later
Yeah.
on. I'm saying um, it's just going to get more and more complex as we have more requirements. And like Dimitri is saying, like we need to figure out now whether this FFI approach works, how much complexity that is versus just treating the service as a proxy and sending those requests to a processee in the same node service, essentially. So think of it as two like processes sitting next to each other, and the orchestrator is getting the tasks, getting the stuff, and then as it gets the task, it just sends it to the service, and then the service indexes and then sends it back through Go. Like really, it should be pretty simple, I think. Like to just do, I could be oversimplifying it, but you just take the request, you pass it over, and then open up
Yeah.
the way for it to go back, right? And knowledge graph handles everything else. So um, that's all I'm saying. If that makes sense.
Cool. So yeah, if you could please point out the reasons why you think that it should be a separate service. If you could put it into issue, it would be great, so we can continue discussion there about this.
Yeah, we will definitely. I just wanted to get on the call with you guys so we can start thinking about it now and get your thoughts. If you're completely against it, like that's totally okay. I'm just outright outlining some of the concerns that I see after looking at everything. So
I'm not saying I'm against it or I'm for it. It's more like it's not. I wouldn't underestimate the complexity of adding this extra service and introducing the service into knowledge graph has complexities on its own. So, so yeah,
is
it's
it,
a
is it
dramatic change of direction of what was the plan so far. So. I would be careful before doing these changes.
what would be, I guess I'm still unclear on what would be the hard part of adding a Rust process in the same node to the architecture, like this new architecture
So,
pattern.
so
Off the
then
top of your head, I mean,
you have to deploy, run, and maintain another service. Then it raises another question: do we actually still need the Zookt service, or would it make more sense to add everything to this new knowledge graph service? Because the node maintenance might be easier to be done as part of the separate service. I think one of options we discussed before was whether we need
But
whether we want to
define
reuse the completely separate service or whether we want to reuse the Zooked service. Yeah.
can you define new service though? I'm a little
Yeah,
confused. If it's
it's
a process, then shouldn't it be just like another line in the Helm chart or no?
sorry, the new service means something like Zooked indexer process, which accepts the tasks,
Yeah.
and but in this case would be the Rust library with the knowledge graph. Yeah.
Basically,
on
a new Helm chart.
So a
Sorry?
new Helm chart.
Sorry, a new what?
So I understood it as Jan is proposing to, or not proposing, this option is to introduce a new Helm chart, essentially a completely new service separate from GitLab Zooked. Maybe I misunderstood it though.
Well, Helm chart will be used for some cloud deployment. I mean, it would be run similarly on the same level as Zooked indexer. It wouldn't be run behind it, but rather as an alternative to Zooked indexer. And I'm not proposing it. I'm just saying that it's another option to consider whether we really need to introduce another interface between two processes on one node, or what is the logic we want to reuse from Zooked indexer if we go this path.
From what I have read in the logic so far, there's a fair amount of logic in the Zook indexer for node registration, heartbeat, um, polling the tasks, sending the tasks to whatever operation that needs to happen, and also has Gitly into it. If we were to say let's completely just vertically
All
integrate
right.
all the way through.
Well, Gitali would be the strong reason to actually
Yeah, if we did
use.
Rust all the way
Yeah,
through, we might need to implement the Gitly client on the Rust side, right? Which would add some maintenance.
And
So
I think we shouldn't discount the Helm chart aspect of it, because we've spent a lot of time introducing this gateway logic when we can route the request appropriately based on the path. So we would need to copy the entire Helm chart. That means that we have duplicate code. If we, let's say, improve or fix something in one Helm chart, we need to go to another Helm chart, do the same, a lot of duplicate logic.
yeah, but we can still add. So let's say we add a Rust process, right? Right? Is that going to be a hard thing to do to add to the Helm chart? Because we don't have to worry about omnibus now, right? So, which that was news to me. That was like one of the major things that got me thinking, like, okay, if we don't have that constraint, we might be making this more complex than it needs to be.
But maybe the Helm chart is also not like big of a reason like to, because you can still extract the common stuff into another template and inherit it into like the Zooked indexer and the knowledge graph if the knowledge graph has its own container. So probably in the Helm chart you can still extract that, but there's like in case so I don't know what the sidecar means. Is it another container within the same pod on Kubernetes, or is it another? So, or we end up with the different service that needs more monitoring, more alerting, all these stuff. The price that we pay for extra service. So it depends on what this extra service
That
means.
part means, yeah. Dimitri,
Yeah,
what are your thoughts?
An extra process in the same container. So we have a stateful set pod, we have 3 containers, indexer, web server, gateway. So we would add one Rust process to the indexer and one Rust process to the web server. And the Go process will handle the lifecycle of both of these processes. So we only need to change the CNG image to include the Rust binary into it. I think that's the only change. We don't even need to change the Helm chart itself.
Yes, yeah, because it's running within the same pod. Yeah, probably it can still be another container. That's what the point of 2 containers. But that's implementation details. I don't want to get into it, and it's only for Helm charts. Okay, probably that's the. I mean, we have another installation methods, but I don't want to talk about them now. Okay.
Oh, what was it? What were you saying?
We have some other, like apart from Omnibus, we also have Kubernetes, and we also have like operators, and also users can install it using Docker or also source code. So there's another methods, but probably we are focusing only on Helm chart here.
Yeah.
Yeah.
At least that was from when I talked to the delivery team. They said we have their full support for getting it on .com. They suggested basically get it on .com first, get it, then we can work with getting it on self-managed, but it wouldn't be through Omnibus, the self-managed solution. It would be through their new, I think it's segmentation strategy is what they called it. So, which is Helm chart based, it seems like. So that means I think they're probably I'll talk to Andrew and Fabian again to get clarification, but I'm assuming that means they're for all Omnibus customers, they're probably for customers that want to add new services, they're probably just like hand holding them and installing a cluster or something in their environment, is my guess. So that's what they may need to do for the knowledge graph, right? But it's good for us because that means we can treat this as an upgradable separate service outside of Rails, if we start thinking about that way, right? Versus something that's packaged with Rails and Omnibus. That's something Shakar and a few other people were saying that would be nice as well.
Do we have any other service where we are taking the sidecar approach, or is it something that's going to be new if we take that approach in GitLab?
That's a good question. I'm not exactly sure. I think usually it's a single process. So we already have two processes, one for reads, one for writes, but we'll duplicate the number of processes. I think that should be fine.
Okay. Yeah. I'm just wondering how it's going to be from like if you want to monitor that, and if you are collecting information from the containers, from the pods about the main running process, but we forget about the other one. What if it like there's some more to it. Probably I don't know so much about it, but yeah.
Well, we're definitely going to be adding observability into the knowledge graph binary itself, right? So like open telemetry, etc. So that will be baked in regardless. But being able to query it might be different. That's what I was saying. Maybe two web servers, they're separate processes, but they're web servers, they talk on an internal port, if that's possible.
But that's yes, that's idea of the sidecar, and probably that's also what, as I mentioned before, like the idea of when Kubernetes pods have two containers running inside.
Yeah,
It's exactly
that way,
for
instead of two processes in the same thing. Yeah. I see what you're saying. We could think about that as well. Like that actually might be a better move. What do you think about that, Dimitri? It's a good point.
So I like the optional nature of the sidecar approach, so that you don't have to run the process and you only run it when needed. For example, we don't have any knowledge graph namespaces assigned to a node. We don't even need to start these processes. So that's what I like in this approach. And we can still figure out observability. Maybe you can pass /metrics or even merge it with the existing /metrics API to expose it to Prometheus, let's say, observability improvement.
Yeah, I mean, these are all things we'll definitely discuss in the issue/document. I don't know. I just wanted to raise this as soon as we could so you guys could be in the loop, right? Because we've been focused on getting, I don't know if you guys saw, we were like really pushing it to get 18.3 out, right? And now 18.4, which is all focused on the local side, but I want to make sure on the server side we're still
we need to answer these questions early. I think that's going to be our next focus. Look, in which direction? Because I am working on the incremental indexing. So the full indexing is like merged, but it's not. We haven't built the image yet. So we tested it partially, and Jan was also working on the querying before going on PTO. So we need to know which direction to go to solve and work on these things. So probably that's going to be our next step to figure out Is it sidecar, different process, or FFI? So we need to answer that early.
Yeah, let's put it into issue and we can focus on it tomorrow morning, our day, so we can investigate further.
I will also think about the deployment approach, because maybe it could be a separate container in the same pod. Maybe that's better, that would follow the existing practices, and
Yeah.
we can still make it flexible. So you can still run it as a sidecar or as a separate container. Yeah.
Yeah. And you can put all the dependencies within that image. And so it's simple. You don't have to worry about the Zoc indexer image at all.
And we already build for all OS, so we should have images available.
I
Not
think
images, but sorry, but binaries.
I
Yeah.
think deployment team wouldn't like having these both processes coupled together because there is lack of visibility or monitoring into both. On the other side, having both in separate containers might mean complexity regarding the communication between both. Yeah,
sorry.
we might need some kind of authentication or stuff like this.
Yeah,
if we
but
need.
it's it's gonna be two containers within the same pod, so they can't access each other, but they cannot access other containers. So it's like I think this is a common pattern. So if they reject it, I would be wondering about that.
We do exactly that for the gateway container. So they see each other ports. So it's exactly the same as these were in the same container. So I don't see any problems with that specifically. Maybe one last point from my side. I think this Rust service should be a separate service, lightweight service, that will use knowledge graph as its first feature, if that makes sense. So it shouldn't be knowledge graph itself, in my opinion.
You mean like let's say it's a web server or it's just a server in general, it's running in a separate container. You're saying it should be a separate project that has
a separate
library in
Rust,
it, or...
a separate Rust crate, and it will use knowledge graph as a library. So in my opinion,
well, yeah, we definitely create a new crate for sure in the knowledge graph. So,
yeah, that's fine.
If you guys are comfortable with that. So why exactly would we do that? Why don't we just treat it as one knowledge graph feature and just I thought the whole point is we're reusing the Zoot indexer logic as much as we can, right?
Yeah, that still stands.
Yeah.
I'm just saying that it would be nice to have this really tiny level of abstraction. Maybe we'll have some other feature, not knowledge graph, we would want to add to the Rust part of this service.
Okay.
So maybe you could even move out Zookt out of the Go portion of it, and would have the main orchestration part in Go, the sidecar part in Rust, and then we'll have a bunch of M+1 feature for each. Hopefully my explanation makes sense.
Yeah, it could do that where you can, and then you're saying like if you want to add a new feature, you can just add it to, as long as it's accepting the schema on the Go side or on Rust side, you can add it in whatever language you want to add it in.
Yeah, exactly.
The problem with our current implementation, is that the Zoc nodes at the moment, they don't know which tasks they are handling. So it's only saved on the Rails side. But maybe that's something we have to align between what's on the Rails side and what's on the infrastructure. So we start 10 Zoc nodes without sidecar, and we start another Zoc nodes but we have to put this information on the Rails side.
Oh, you're saying wouldn't you always have a container paired with each Zoc node?
Not all the Zoc nodes will be for knowledge graph. So the plan is to have Zoc nodes for the search and Zoc nodes for the knowledge graph. That's the idea.
Well, yeah, that's
You
what I was
want-
saying. When I was looking at the Rails code, it seems like it's kind of piecemealed in there versus I feel like you could abstract it into a service where the service declares its capabilities. I'm declaring knowledge graph, I'm declaring Zookt, and it adds the rather than needing to create a separate folder for knowledge graph and all the tasks for knowledge graph, right? That's at least from what I saw.
It's at the moment it's all on the Rails side. So Rails tells it, okay, you index this, you index that, and like the whole code, like code base, it just does. But now there's more like it's more complicated because it needs to know in advance so that we add this container or we don't add this container. So, but yeah, we will figure it out.
Yeah, we would need this Zook site information anyway, because I wanted to discuss this after vacation, but what connection pool does is that it works with some predefined amount of memory. So it needs to know in advance how much memory it can use for open connections. Yeah, for example. So it means that we need to tell Zookt indexer when it starts, you can use, for example, 10 gigabytes of memory for knowledge graph connections. Yeah.
You're saying
So
source that from Rails, or where would that come from? Can that not happen in the club
so
itself?
so on Rails, we currently just store the information. No, it shouldn't come from Rails. I think this should be information we configure together with nodes, like telling it how much memory it can use for Zooks. I don't think this should come from Rails. On Rails, we
No, yeah,
currently,
definitely.
yeah.
I actually think if we use a separate container with its own limits, that's better because we know exactly how much memory we could use.
Yeah.
Yeah, but not all deployments will be in containers, so we need to set the limit anyway.
Would that be configured via the Helm chart, or where would that be configured, I guess is the question. Where would it be configured via some panel?
So my original expectation was that it would be part of the node definition. Yeah, so the Helm chart for the Zookt node.
Okay.
I mean, you have to put limits on the containers anyway. It just question is now that the application has to be aware about this limit. So you have to pass this information to the application as well.
By
Yeah,
application, do you mean the Rust process? I'm sorry.
Yeah, in this case, in this case, Rust process. Yeah.
I think it should be able to read the current limits from Kubernetes, if I understand it correctly.
Yep. Or we can read it from environment variable.
Yeah,
Also
for example.
possible. That's what I'm saying. Like, if we have that, we're going to be duplicating that logic on the query side. So yeah, I just think the more we vertically integrate, the better, while reusing what we can where it makes sense. In that case, the Zookt indexer for all the orchestration. And treating knowledge graph as a vendor, really. So a little bit of a mental model shift, but yeah, that's basically what I was thinking from everything I've seen. But well, let's create an issue. What do you guys prefer? Just create an issue? Is there an existing issue that we want to use that one that we kind of just started discussion on? I feel like we need its own issue. What do you prefer, Jan?
Yeah, I think that a new issue would make sense. Would be best to discuss this change.
It feels like the first issue in a new epic, honestly. Like a spike issue.
We can change